Now to make a schematic diagram for this logical gate. Since we have two inputs, we must include two transistors and an LED to indicate the output. Two switches to control the input to both transistors, the battery, and three protection resistors. When the battery is connected, current flows through R1 to SW1. Since the switch is off, the transistor remains off or non-conductive. It also travels through R2 to SW2, and again this switch is off, so this transistor remains off. The current continues through R3, but since both transistors are off or set to 0, the LED does not light since a complete electrical circuit cannot be made. So when both inputs are 0, the output is also 0. Let's reset the circuit and this time close SW2. As before, the current travels through R1 to TR1, but since the switch is open, TR1 is not made conductive. The current continues through R2 to SW2 and turns TR2 in a conductive state, allowing current to pass through the transistor from the collector to the emitter. But as TR1 is still off, the circuit cannot be completed and the LED remains off. So when the input is 1 and 0, the output is 0. Now we should close SW1. The current flows through R1 and the switch turning TR1 on. Now current can flow between the collector and emitter of this transistor. It also travels through R2, but since SW2 is off, the transistor is not conductive, so a circuit cannot be made, and again the LED remains off. So when the input is 0 and 1, the output is 0. Finally, when both switches are closed, current can flow through R1 to TR1, turning TR1 on. Also, current flows through R2, turning TR2 on. Current can now flow through TR2 and TR1, completing the circuit, causing the LED to light. Therefore, only when the input is 1 and 1, the output will be 1.